Welcome once again to e.t.c blog. This section we are going to treat scalars and vectors, but before we enter into the teaching place, always remember this is your jam pass question. Always go follow the link and go get your jam pass questions, your posterior pass questions, your wire pass questions. We have more exercises on each topic. So this particular topic, if you go to the exercise section, you always have more questions. Please always go to our YouTube channel, subscribe, like, very necessary for us, please, to promote our YouTube channel. You can also share to your friends any questions you need or you don't know how to solve, or the ones that I've solved already. You don't know how, you have any question based on that, please leave your questions on the comment section below. Okay, thank you very much. Now let's move over to the lesson properly. Now we have our lesson objectives. These are the things we need to know about anything concerning these scalars and vectors. We have definitions and examples of scalars and vectors. What is resultant vector? What is a resultant vector? Now we have methods of solving vector equations. The next thing here is the resolution of vectors. This, I don't think we have much problem, but we are going to explain it very well. But our main focus in this particular topic is on vectors. We don't need to know what scalars are, but where we solve questions is on vectors. After solving this, I don't think we have a problem. So quickly, let's go into the definitions and examples of vectors and scalars. This is the definitions and the examples of scalars and vectors. First, what is a scalar? Before I define what a scalar is, please, you can call it a scalar, or you can also call it a scalar quantity. This can also be referred to as a vector or a vector quantity. It does not matter. Now, a scalar, by definition, is any quantity you know in physics that has a magnitude. Magnitude means size. That has a magnitude, but it doesn't have a direction. Anything, any quantity you can think of in science as a whole that has magnitude, that is size, without a direction, is called a scalar. Now let me put it down. Okay, this is a scalar. A scalar is any quantity with magnitude, which is also called size, but has no direction. While the opposite is actually a vector. A vector is any quantity in physics or in science as a whole with magnitude and also direction. Any quantity you know that has a particular magnitude and also a direction, that quantity is called a vector, or you call it a vector quantity. So I'm going to put it down too. So you can see the definition on the board. A vector, or you can call it vector quantity, is any quantity with magnitude and also direction. So the difference between a scalar and a vector is that a vector has direction, while a scalar has no direction. So I'm going to explain this very well. The definitions are easy, but sometimes the understanding is not all that easy. So I'm going to use some of the examples to differentiate. Now let's say at this side we have a scalar. We have scalars here, while here we have vectors. We can pick any quantity of our choice, and let's know whether that quantity is a scalar or a vector. Now, first of all, let's pick distance. For instance, we have distance. Now, distance is a scalar. Why? Somebody can just, let's say for instance, somebody can tell you, I walked 40 kilometers. I walked 40 kilometers. Now, the magnitude of this quantity is 40 kilometers. But the person never told you the direction he or she walked. So in that case now, you can't call Since we don't know the direction of this particular magnitude, of course, we know that it is a length. A distance is a length because of the unit. We call it a distance. And a distance is a scalar quantity. But let's say the person now said, I walked 40 kilometers to the north. I walked 40 kilometers to the north. This time around, it has a direction. We have 40 kilometers north. In this case now, this is no longer a distance. It is called a displacement. It is called a displacement. Now, a displacement is a distance that has a direction. That is what you call a displacement. Therefore, a displacement is a vector, while distance is a scalar quantity because of this direction north. Another example we can use to clarify this is speed. For instance, if someone asks you to classify speed, whether it's a scalar or a vector. Now, speed, for instance, if you watch vehicles, some vehicles are always written on them. Let's take, for instance, these ones that carry sand. You always see something written as 56 kilometers per hour. 56 kilometers per hour. This is a magnitude. So if you are told that this particular truck carries sand and it moves with 56 kilometers per hour, this is just a magnitude. That statement is not telling you where that particular truck is going to. So at that point, this is referred to as speed. Since it has no direction, speed is also a scalar quantity. But if I want to give direction to this, everything changes. I can say 56 kilometers, the truck is going at 56 kilometers per hour due east, or 56 kilometers per hour east. Since I've given that truck a direction, this is no longer a scalar quantity, it is now called a vector. And once a particular speed has direction, it's no more called speed, but you call it velocity. Therefore, a velocity is a vector quantity, while a speed is a scalar quantity. I'll use another example. We have mass, and we have force. Somebody can simply say this particular substance weighs 20 grams. I can say a stone weighs 20 grams. That is all the information I know about the stone. That the stone weighs 20 grams. No direction, nothing concerns me. So at that point, this 20 grams is referring to a mass. And since it's only the magnitude, the size of that stone that I know, no direction, this is called a mass. And a mass is an example of what? A scalar quantity. But force, any force has a direction. Either you are pulling or you are pushing. There must be a direction. Whether pulling or pushing, therefore a force is an example of a vector quantity. We have some other vector quantities. I'm going to put them down and write, note them. Note all these vector quantities, because if JAB is going to ask you questions, they always speak from these vector quantities. So note them very well. I'll put it down. We have on the board the examples of scalars. Please note these examples, very important. If they must ask you questions, the questions will come exactly from these examples. Whether it is post-TME question, especially those writing University of Nigeria Soccer. Now we say examples of scalars. We have temperature, we have distance, speed, mass, density, volume, current, time, and more of them. Now, the current, time, all of them are all scalars. We have examples of vectors, force, displacement, velocity, momentum, moment, acceleration, electric field. magnetic field, gravitational field, magnetic flux. Please be very, very, very careful with these ones. Magnetic flux, electric current density. Please be very careful with this. So these are examples of scalars and vectors. Now the next thing we are going to do, if you have any questions or any other quantity that is not here, but you want to know whether it is a scalar or a vector, please drop your question on the comment section below. Okay, now we'll go over to what is a resultant vector.